Welcome to this section where we're going to be doing the Raspberry Pi 3 with the Python SDK to connect to our AWS IoT console. Now, I want to divide this section up into 3 lectures. The first two actually are going to be more of like bookkeeping lectures. Not super fun, but pretty necessary. In this one, we're going to do what we have already done in the MQTT tool setup portion. We're going to provision AWS with its certificates and policies to be able to talk to our Raspberry Pi. Then in the second lecture, we're going to put the Python SDK on Raspberry Pi, as well as put our certificates on there, and put the AWS CLI. And then finally, in the third part, we're going to do the fun part. We're going to take the basic pub/sub program from the AWS IoT Python SDK and change it to deliver that JSON packet with our sensor data and put in our certificates and MQTT endpoint. Now, before we get started with this lecture, I'm going to ramble a little bit just to give you some background here. Now, in the previous sections, we've dealt with the ESP8266 in JavaScript, and I plan to add a C example. Then the more powerful ESP32 that can use that Xeranth in Python to talk to AWS IoT. Now, we're going to use the Raspberry Pi, which is a single board computer, and often I have clients that want a device-to-web integration guide, device-to-cloud, which is the work I do, and then I find out they're using a single board computer, which runs an operating system, has an application processor, is a bigger form factor, takes more power. It's not normally what I do. Do I consider single board computers like the Raspberry Pi part of IoT? Well, I do because they're portable and they can handle sensor data. But oftentimes I just tell them, look, if you're going to be using a single board computer, really what you want is not a hardware guy like me. You want a straight software web guy. Because there is some device things to do with the Raspberry Pi, but a lot of it's going to resemble more of what you do with a straight client-to-server type programming. And in fact, in some applications, you're better off just using HTTP or RESTful commands up to AWS without going through AWS IoT, because you're not truly doing an embedded device. You're doing a single board computer. And a lot of people don't realize that. And I know the Raspberry Pi is really popular with software guys that want to get into hardware. So I just want to tell you this, I'm doing this, and I think it's good to do. I'm going to be doing an example in Python, and probably one for the Raspberry in JavaScript, or actually it's Node.js. I don't think it's really appropriate to use the C SDK in Raspberry Pi or any SBC, because if you're going to use a single board computer, why deal with a low power, high efficiency, difficult to program language like C when you can use a higher level, more abstracted, less coding for power language like Node.js or Python? So that's why I want to stick to these languages, even basically I'm an embedded C guy, but that's kind of the reason. So that's kind of my feelings about the Raspberry Pi and doing this kind of stuff. But there is a big demand for people that want to do SBCs, and I know that's of interest to a lot of people taking this course. So my first suggestion is, before we get into this lecture, go over that previous lecture on the MQTT FX tool and how to provision AWS. That's the first part of that lecture, because we're going to be doing almost the exact same thing. Now, in that lecture, we set up security certificates to 3 we needed: the private key, the root certificate, that's your X509, and your client certificate. In this one, we're doing the same 3 certificates, and we're also going to get that inclusive AWS IoT full access policy and attach that. Now, previously, we used this secure to set that up, added the certificates, and did an inclusive policy. In this lecture, I'm going to do it via the onboarding, which is going to accomplish the exact same thing. I can do it either way. I can also do it through manage and create a new thing, then make the policy and attach the certificates that way. So they give you 3 different ways to do one thing. So I think I am just going to create a new thing, because then I can save provisioning the SDK on the Raspberry Pi for the second lecture rather than doing it this lecture, which I would have to do if I just go to straight onboarding and download those additional files. So let's go ahead and just create a new thing. Now, what was nice when we used Xeranth and Mongoose is that it did this for us. So it created our things, our certificates and policies for us. When we did the MQTT FX tool, we had to do it manually, which is what we're going to do here. That's again why I suggest you review that lecture. But let's go ahead and create a new thing. And we're going to just create a single thing. We're not going to create a fleet of many things. So let's call this one my rasp, and we'll just say PY. My wrap py. That's a pretty terrible name, but we'll go with it. We're not going to select a thing type. That's if you have a bunch of them. It's kind of helpful to do that for device management. We're not going to add it to a group, and we're not going to have a key value pair. So let's go on to the next thing. And we're going to do what we did previously. We're just going to download our 3 certificates via one click. So let's go ahead and do that. So assuming you took that lecture, again, we don't need our public key. We'll download this certificate. This is our private certificate. And remember here, when we put it in its own separate folder, it starts with CDF7. So we'll remember that. So let's save that. We got our client certificate. Let's get our private key and save that. And then finally, let's download our root X509 certificate. This is just going to open up again another browser window. We'll just copy and paste it, and then I want to force save it. So I'm going to put it over here in Notepad again, paste it over here. The last one I saved is a .pem. I think that'll still work, but this one I'm just going to force save it in the next lecture, just to let you know, as like X509 root.crt. Our Python program is going to understand that a little bit better, although I think it'll work with PM too. I don't think it so much cares about the file extension. I'm going to do that in the next lecture. So just make sure you've downloaded these 3 certificates. You have them over here in your download section. You got this one, you got this one, and you got your X0509. I'll go ahead and activate all 3 of those. Successfully activated. And let's go ahead and attach a policy to our certificates. So these are our previous policies, and we're going to want to go ahead and create a new one, or we can recycle an old one. So we can really do it either way. We'll go to policies. Now we have these old policies, and to be honest with you, these all have pretty much the same policies. So we can go ahead and look at, say, the one Zeroth created. We'll see that it created the exact policy we need. We're going to create it a little bit differently than we did before. This one was auto-generated, but again, if you went to the MQTT-FX lecture, we manually created a policy like we're going to do here. So I'm going to go ahead and create one, and we're going to call it my Raspberry policy. So my Rasp policy. How about that? Another terrible name. And before we went to advanced mode, and I copy and pasted in this AWS full IoT access policy, which is exactly like the one I just showed you that Zeroth created automatically. Just to remind you of what it looks like, I can go ahead and hit advanced and copy this exact policy in. I'm not going to do it this time. I'm going to switch it up for you to make it more interesting. I'm going to use this action resource effect type pre-made template. So what's our action? It's just IoT : everything. We don't want that as our ARN. We want everything. So there's our ARN, and I'm going to hit allow. So this is going to create the exact same policy. So let's just go to create. And let's go check out that it actually did what we wanted to do. Let's go back in there and let's look at the policy it created. Pretty much everything we need, all-inclusive IoT access. And let's make sure it kind of matches this policy that we want, which is the AWS IoT full access policy. Action, IoT : everything, resource, everything, that wildcard. Go back here, allow everything, resource, everything. Great, this is the exact same policy. So to attach that policy to it, let's go over to security certificates here. And remember CDF, these were the 3 certificates we just got, and we just made that policy. So let's go ahead and attach a policy to it. We got to scroll down. This is the last policy we made. They're in chronological order of when we created them. So let's go ahead and attach this policy and then make sure it's activated. So good, we attached it. Let's go check it out. Let's make sure we have that policy attached. There it is. And it's got the right policy attached. That's great. And we can make sure it's activated by just going into secure certificates. We can see, unlike the previous example, it's defaulted as activated. Okay, so the only thing I'm going to do, I don't need to show you, is I'm going to move these 3 certificates from our download section, our Notepad, over to our separate folder, and then we'll get into our Raspberry Pi and setting up our Raspberry Pi for our Python script. So let's do that in the next lecture. Okay, in the last lecture we worked on provisioning AWS for our Raspberry Pi and Python program. We've created those 3 certificates and we've defined that full IoT AWS access policy to our certificates. So when we load them on our Raspberry Pi, we know we have access to that IoT console. So the last thing I wanted to do as far as that is, we had this CA root certificate saved because just open that screen as plain text. So let's go ahead and put this with our client certificate and our private key. So I'm going to hard save this, and again, this is what I did for that MQTT-FX tool setup, so if you've done that lecture, this is going to look really familiar. But remember that CDF7 blah blah blah, that's our private key and our client certificate. This will be our root, so I said I was going to call it X509 root. And before I ended it with PM, I don't think it matters, I'm going to end this with CRT, but I've already tested that Python program and it can handle this, and I believe it can handle the PEM. But hard save it that way, again, if you have a Mac or a Linux machine, It's going to be done differently, but just make sure you're using a text editor with no special characters. And I'm going to go ahead and save that into the directory, and then I won't need this anymore. And then when I use our FTP file transfer program to move it over to Raspberry Pi from our local machine, we'll have all three of those files in the same place. I do want to get one more thing out of here, and that's going to be, if I go over here in settings, this familiar endpoint right here, custom endpoint. We're also going to need to code that into our Python program. So I'm going to copy this, and I'll just stick it in the same place. Just stick it right there, and I'm going to say file save as endpoint. This I can use as a text, because I'm just going to use it for reference later, and I'll stick it in that same file. Boom, right there. All right, so we're done with that. So what we want to do next is get to setting up our Raspberry Pi and installing the Python SDK into Raspberry Pi, and then installing the AWS CLI interface into Raspberry Pi. From there, we can take one of the example programs in that SDK, alter it for our needs in the next lecture, upload it to our Raspberry Pi, and we're good to go with sending JSON data to our IoT console in AWS. So let's go ahead and do that. So what I want to do first here is go over to PuTTY and log into Raspberry Pi. Now, I'm not going to support Raspberry Pi. And if you have different versions of Linux installed on Raspberry Pi, it's going to operate differently. I have the most basic version on my Raspberry Pi. I have this Rasparian Noobs Jesse edition. You might have a newer edition coming out. That shouldn't change. Now, I will say a couple things on setup. There's all kinds of articles on setting up Raspberry Pi for AWS IoT and just setting up Raspberry Pi in general. And they all say a bunch of information that's not useful or not correct, as far as like you have to click on network sharing, blah, blah, blah. You have to use advanced IP and search for the right IP4 version address. I didn't need to do any of that, but there was a couple things I needed to do on this version. I needed to make a blank file called SSH in my boot directory, and you guys have probably already done this. And from PuTTY, what I found the easiest way to log on is just to say raspberrypi.local, and then it knows where to log on to, and I keep it as port 22. That's generally your HTTPS port. Port 8883 is used for MQTT traditionally, and port 443 is used for WebSockets, but any port can be assigned to anything. I think port 80 is just normal HTTP without the security. So let's go ahead and log on to this. I'm just going to open this, and I have my Raspberry connected via Ethernet cable. There's two other ways to run a Raspberry Pi. You can do it as a standalone, which is the most basic non-IoT version, which means you hook your HDMI adapter into your monitor and attach a keyboard and mouse directly into your Raspberry Pi. Doing it through an Ethernet cable called the headless setup is what I'm doing here. That's why I'm doing SSH via PuTTY. If you want to be really cool, you can connect it via Wi-Fi by using port forwarding. That would be the really IoT way to do it, but I'm not going to do it that way because it's going to add some additional complications. But just realize there's three different ways to set up your Raspberry Pi. So let's get and open this, and it's going to open that SSH window. I haven't changed the login, so if you've done a normal login, you're just going to log in as Pi, and then your password's going to be Raspberry. And you can, of course, change that to something else if you want. Now, I've already installed SDK. So if I list my directories here, you'll see I have my AWS IoT device SDK, but I will put in instructions on how to do that yourself. So you'll know how to do that and install your own SDK, which will be much cooler if you do it yourself. So I'll put that on the screen as something you can do yourself. Now, you already should have Python running on your Raspberry Pi, whether it's Python 2.7 or Python 3.0. AWS has made it so their SDK will work with either version, which is pretty handy. And we're going to go over this pub sub sample, but it kind of goes through how to set that up. So starting here, you should check your version of SSL. If you've gotten your Raspberry Pi recently or have done an update, you'll have the most recent version. I think it requires 1+. And from there, you're just going to use this git clone HTTPS and clone the GitHub for the complete AWS IoT Python Git. From there, we want to install the second thing, which is our AWS CLI. It's going to be the same as what you've already done in computer. You're going to say sudo pip install AWS CLI. And then from there, it's going to ask you 4 different things. It's going to need your access key, your secret key, your default region, and your output format, which we set to JSON last. This is going to be exactly the same as what you've done on your PC. So where do you find these folders if you need to look for them? You're just going to go over here, and when you did your CLI, it installed a folder called .aws on your local machine. So go to your local machine, whether it's Linux, Mac, or PC, and you can start out looking at config, and the config file here is going to hold your local region, whatever it is, and JSON format. Those are the last two things you need out of the four. And then your credentials, which I'm not going to show you my credentials, are going to have your access and your secret key. So when you type in AWS configure, it's going to ask for these four things, and now you know where they're located. Now, assuming you lost all these, that's fine. You can just go to AWS, go to your IAM, and look under your credentials, and it'll have your key and your secret access. So you don't even need to go to the file. It's just easier to check your local machine file, and you'll keep it with your region. I'm in North Virginia, so I'm US West 1, and I want output as JSON format. Okay, now if you successfully puttied in there, let's go back to putty here and let me center this a little bit more. There we go. We can check out what our directory is. So let's go ahead and change into this directory, and we'll go in here. I'm just going to dig in here to show you where the sample files are and show you the basic pub sub we're going to alter. So it's under samples. And within samples, I have basic pub sub, basic shadow, green grass things. So you get some pretty good examples. And within basic pub sub, you're going to see I have my Python file. And I've made a few different ones. And I've made a cert file. So go ahead and within this, make your own file in here, because I'm going to make it easier, because when we get to our Python program, it's going to ask for where your certs are. If we stick our Python program exactly where we put our certifications, then we don't have to make a file path directory. Even though it's not really the correct way to do it, it's going to be the easiest way to do it. So I'm going to make another directory in here. I'm just going to call it, actually we have to use the sudo command as the super user do. I'm not a Linux expert, but I remember that. Make directory. We'll call this our folder, our fold. In the next step, we're going to move all our certificates over there so they're ready to go. Then I'm going to show you that Python program before we start altering. And then after we alter the Python program to send the JSON packet the way we want it, we'll upload it back to Raspberry Pi from our local machine, and then we'll run it and it'll be good to go. So there we go. And now we'll just switch into that directory. And it's just going to be an empty directory. So the last step we're going to use here, I can close this out, we're done with this for now, is we're going to go into our FileZilla. Now you can use any kind of file transfer protocol program you want. FileZilla is free. So I'm going to log into the same host, RaspberryPi.local. And our username, as you remember, is Pi. Again, I'm just using the default that came with it when I bought it. And the password Raspberry. You can change these. And remember what port we're using. I believe it's 22. That's your open HTTPS point. So let's make sure we got all this. RaspberryPi.local, Pi, Raspberry, port 22, quick connect. It's going to show up here our status. Excellent. We're able to get in here. Everything's okay. So from our home directory, we can start digging down. Go into here, go into samples, basic pub sub, and then we have our folder directory. Great. Now we're just going to stick our files into this folder directory, and there's one more thing I forgot to do. And I have to change the mod on this folder or nothing's going to work. So I have to change this to super user. So the way I'm going to do that is sudo chai mode, change mode, 777. There we go. I was able to do that now. So now we should be able to access that folder. So let's go check that out when we can. So I'm going back to where we saved our 3 certificates. I'm just going to save all these in here. We don't need to use this endpoint. That's just a reference for what I got to use later. So I'm just going to keep that out for now. So I'm going to save this, this, and this. Move this all over to our folder. Boom. Good. Transferred successfully because we gave it access. All right, we're almost done here. The last thing I want to do in this lecture, now that we've been able to configure and do all that, is I'm going back to the AWS IoT Device SDK for Python. This is owned by Amazon, and this is on GitHub. So this is what the basic pub sub file looks like in Python. This is held, as you've seen, locally in Raspberry, and I can go to sudo nano, which is an editor in Raspberry, and I can edit this. I really don't like nano, VI, Emacs. I'm not a Linux guy. I don't want to start editing this. You could do it if you want. So I'm going to edit this in Notepad++ outside of Raspberry. And then, of course, I'm just going to stick it back in Raspberry. That's going to make my life a lot easier. So let's go ahead and stick this over here to whatever local editor you have. And so now it's held locally. I'm going to alter it. And mainly what I need to alter here is it's going to ask where my certificate's held, where my private key is held, what my endpoint is, and what my topic is and my messages. So I'm going to alter this stuff in the next lecture when we edit our Python program. And after I finish altering this, I'm going to upload that to Raspberry Pi, run it, show you the AWS IoT console, and then we'll be done. So let's go ahead and do that in the very next lecture. Okay, welcome back to the course. Now this lecture is going to be the fun part compared to the previous two lectures. So in the first part for our Raspberry Pi, we were just provisioning AWS. And again, that provisioning we did was the same as provisioning it for that MQTT-FX tool. So if you're confused about that part, just go back to that tool section. It's the same thing. We're basically getting our 3 certificates, and then we're getting a policy for those certificates. And in the second part, we had to configure our Raspberry Pi for the AWS SDK for Python. Now that we've done both those things, we're ready to move on to the fun part, and that's getting our Python code, doing our altercation to send up our sensor JSON package, and then running our program and seeing that it works in the AWS IoT console. So let's go ahead and look at the Python code we're going to start with. As I've told you previously, it's included in this AWS IoT device SDK for Python. But let's go ahead and copy this, and we're going to stick it into our editor. And you can use whatever editor you want. I'm just going to use this Notepad++. So paste it right in there. And I'm going to go ahead and save this as a Python file. So I'm just going to go ahead and save this. And I already had it listed as a Python file. And I'm just sticking it in this directory on my desktop. I called it BSP basic pub sub 4 with the .py for Python file extension. And of course, I'll include the altered file. If you want the original file, that's just held on the web on the GitHub right at this address over here for the AWS SDK on GitHub. Now, you already remember in Raspberry Pi, if we go back here, we created this folder called our folder, and if we list what we put in there, we put in our 3 certificates, our root certificate, our private key, and our client certificate. Now, I noticed this ended with TXT instead of previously ended with that certificate CRT extension. That's not a big deal. Python's way more loosely defined and typed than C, so it can look at the headers and figure out what these extensions are. So whether you have the TXT extension, which got added accidentally or not, you're going to see when we transpile to Python, it's very relaxed about how it handles that. And I've checked it ending with .pem, .crt, .text. It works either way, so that's really nice. So let's go ahead and back here and look at this code. And I'm going to go over and explore this code really briefly, and then we're going to start making our altercations. And then we're going to actually upload it back to our Raspberry Pi and run it from there. So the first thing we do is import a bunch of libraries. The most important one is this AWS IoT Python MQTT. This is based on that popular Pi-ho MQTT library, and then it's just altered by Amazon to handle their stuff specifically. And you'll see a little bit later, they do some custom configurations within that library. These are all standard Python libraries. Now, again, what's important to note is this is a full Python 2.7 or 3.4 version. It's compatible with both. We had previously done Xerath in Python, and we had done Mongoose in JavaScript. Those were constrained libraries. They had special names and special defined functions. So again, for a prototyping platform, that's really helpful. For a production platform, I would still recommend doing it in C. But for prototyping in this course, it was great to have the ability to use a higher, more abstracted language like JavaScript or Python. Now, when doing a single board computer like Raspberry Pi, being able to use full-blown Python or full-blown Node.js or full-blown Java, which these IoT SDKs from Amazon give you, is a huge benefit. So this is a really great reason now to use an SBC as we get full use of the Python language, which is super helpful. So that's great. So let's go over this. So we import our libraries, and right here we're adding arguments. Now the 4 arguments we're going to do first to change is under this help. We're going to put in our custom endpoint, our root certificate, our client file certificate, and our private key. So I'm going to do that after I explain a little bit more of this code. So another option here is it's going to say, do you want to do publish, subscribe, or both? We're going to use both, but we're not really going to subscribe. We're just going to publish our JSON package. If we want to do more advanced functions and have AWS send a message to change our code, we would subscribe to a topic from AWS and be able to actually alter our program on the fly. We're not going to do this here. We're just going to be publishing our JSON package. Another option you'll see here is it has WebSocket capability. Again, that WebSocket goes over port 443. Normally, you don't need to use WebSockets to wrap MQTT. If you're doing an inter-application program where you're not worried about firewalls, you can use WebSockets for full duplex communication. But for most IoT apps, you don't want to use WebSockets. We're not going to be using WebSockets here, but this program again adds a lot of extra code because it gives us the use of adding WebSockets. The final couple things I want to show you, this is the more advanced stuff right here. This again goes to that MQTT library. It talks about draining time, timeouts, this and that. We normally don't want to mess with this custom configuration. So it's nice that they included these code samples because later on I might do an easier example and it's not going to include any of these more advanced functions, but just leave these all to the default. The big thing we're going to have to change is at the end here. So all this stuff up here is run once, and once it's run, it's never going to look. This is going to loop and give us a loop counter, and it's going to continually send us messages. So what we want to do is add our Python object, or in C we would call that our data structure or instance of class, and just keep sending our sensor data every loop cycle. And we'll change this time so it doesn't update every second. But based on it uses this JSON dumps, which is the JSON encoder. If we want to decode it, we would use that JSON loads. But here we're going to take our message, use JSON dumps to encode it, put it into another variable, and then send it off to this argument. This is what sends it to that MQTT publish. And again, if you've done the zeroth lecture, this looks almost exactly the same. We have our topic here, our message, and then our QoS level. There's another variable you can add, but you actually only need the topic and the message. You don't even need that. Because as I remember on the Amazon side, the quality of service is listed as 0 anyway. So the topic is the final thing I'll talk about. The topic here by default is listed as SDK test Python. So when we subscribe on AWS IoT, we'll subscribe as SDK test Python, but we can change this to whatever I want. So let's go ahead and alter this. So here's what I'm going to alter, and I don't want you to sit there while I'm typing it because there's no point in that. We're going to alter this. We're going to have to put in our custom endpoint, which we already have, our root certificate, our client certificate, and our private key. Now you remember they're already over here. We saved them to this folder. We have to put in these exact names. So there's the 3 we need plus our endpoint. So that's what I'll do. And if we go over here to Raspberry, we'll see again, if I list this out here, we already have these exact same certificates in our folder. So let me put in these 4 fields, our endpoint and our 3 certificates, and then I'll come back and we'll alter the rest of the code. Okay, now that I've entered those certificates and our endpoint, you can see right here, the endpoint goes under here, help. If there's a default, it'll go there first. But this is the link to the endpoint. There's our root certificate, our client certificate, and again, this ends in txt. For whatever reason, if I look over here at Raspberry Pi, when we stuck it in that directory, we got this txt extension. If you don't have this, you just have the certificate extension. That'll actually work too. Just make sure the certificate names match. I got my other certificate in here, my private key. And those are the only 4 I need. So I got those 4. I also imported the random library. Again, I'm only pointing out the differences between the AWS SDK and my alterations. And of course, for the same reason I did in Zenith, I switched this import of random to bring in this library to generate a random number for our humidity and temperature data. Now, if I really had a DHT11 or a DHT22 attached, doing this in Raspberry Pi hardware prototyping and using this library is about 5 times easier than doing it on an ESP8266 or TI3200 or ESP32. So you can look at all kinds of examples of DHT11 on Raspberry Pi. Super easy to set up, super easy to use that in the GPIO library. So I may do that at some point, but I'm not going to do that now. I don't want to do any hardware prototyping to make things more confusing. Now, the biggest change I made is I put in this Python object. So our Python object, it's like a data class that has our device ID, time, temperature, and humidity. Again, using that random library, I'm just using a random variable between 0 and 100 for temperature and 0 to 50 for humidity. I brought in, I didn't have to bring in actually, it was already part of the code, the time library. So time.time function, it'll give you that current UTC stamp. Unlike these other prototyping libraries, there's a million ways to use time. So you got a whole options more than you had on these other embedded devices as far as how you want to manipulate your time sequence. And finally, I think using like a client ID or UUID, we can get a callback with our certificate name, which is our thing name. I'll probably do that later. I didn't see it immediately available, so I just typed in Raspberry Pi 3 CDF7 as our certificate, just so we can uniquely identify this device ID. So if we have multiple devices, we know where it's coming from. Finally, I use this JSON encoder, JSON dumps, to take that Python object and put it into JSON format, then send it off in this string. And the very last thing I did is change this delay time from 1 second to 3 seconds because I didn't want it spamming data. And if you change it, just make sure it lines up with here, because if you line it up with here, it's going to spam way too much data too fast. Okay, now that we've got that, I'm just going to save it. And I saved it into the same directory as we put our certificates right over here. I called it our basic pub sub. So let's open FileZilla and put it into our Raspberry Pi with our FTP. So I'm just going to move this over here and put it right over here to the correct folder. So now that it's in there, we can do the rest of this in Raspberry Pi. So let's go over here to our Raspberry on PuTTY. So if we do a list search here, a directory, we'll see that our program is in there, our basic pubsub.py. And again, if you want to edit it in Nano, you can just say sudo superuser do, so you can actually edit it and change it, and just go to our basic there. And you can go in here and you can do it in Nano. Again, I didn't want to do it in Nano. I don't like using this, so I didn't do anything in Nano. All we have to do now is compile our program, and if everything's done correctly, it'll work. So we can go sudo python. I don't even know if we need a super user for that, but I just use it. R basic pub sub.py. Now, if we do this, it's not going to work, and I'm going to show you why. It doesn't give you much of a message. This is an AWS specific message, not a Python syntax message. It says error argument endpoint is required. Actually, it's not just the endpoint. For whatever reason, you got to flag these parameters in the command line, which is odd because it's transpiled and we have this hard coded in our program. So I don't know why you have to do this. At some point, this probably will change. So what you really have to do is add this .e.r.c-k, then it'll work. So I'll go ahead and put that in there, and they have to have our name matching the same certificate names that we just put into our program. So I'll go ahead and do that, then come right back and show you how that works. I don't want to sit here typing it. Okay, I've entered it all in there. I probably actually won't give you this line because your certificates and probably your program name are all going to be different. So you're going to basically have to change everything. But just understand it's sudo superuser do python, our basic Python program, which would normally be enough to execute and transpile a Python program. But in this point, we need to have this endpoint flag, our root certificate name, our client certificate, and our private key. So before I execute this, I'm just going to go real quick here to AWS, make sure we subscribe to the topic in our program so we're ready to receive those messages. So we're good to go. So we'll just go over here, enter, execute this, and hopefully everything will work out correctly. And there we go. So we're getting this function here, time, temperature, and our device. I will make one comment that this is out of order. And the reason it's out of order is Python optimizes this. I don't know why. I consider it's an inefficient language to start with, but it optimizes it. So you would have to import collections and order dictionary to keep that order the way you wanted it. I don't want to complicate it with that Python specific code, and it's very easy just to move this around when we get into AWS QuickSight, so I don't care that it's not in order. We can put it in DynamoDB and structure it any way we want, so that's not super important. Let's go over to Amazon AWS, and we can see here we're getting our messages, and we can see they're changing because the time is continually getting updated here every 3 seconds, and we're getting different humidity and temperature, and our device ID stays the same, of course. And we can also use the code if we want to publish from AWS and send something to a Raspberry Pi, but we're not going to do that. Okay, so hopefully this is useful for you in Python. I'm thinking again about doing this in Node.js and Java and just doing this lat lecture. Now that you know how to provision AWS and you know how to set up Raspberry Pi, that's not really going to change whatever SDK we decide on using and whatever language we decide on using. It's just this last lecture that's going to be different for our code and how to alter it. So hopefully that was helpful, and I'll see you in the next section.